In this video, we're going to go over what happens when you find the power of a product, what happens when you find the power of a quotient, and then practice simplifying different expressions. We'll begin by talking about what happens when you find a power of a product. We'll be writing the expressions of the product of two powers. Then we'll write a general rule to find a power of a product. Here we have 2 times 5 raised to the second power. In this instance, we notice that we have two different bases, a 2 and a 5, with one exponent, the 2. So what we're going to be doing is taking that exponent of 2 and distributing it to each base. Again, our 2 and our 5, which is going to give us a 2 squared times a 5 squared. We've written this as an expression of a product of two powers, and so we would be done. If we were trying to simplify this completely, we would need to continue this, and we would have 4 times 25 or 100 for our final answer. You could also plug that into the calculator and get 100 as well. But since we were looking to write the expression as the product of two powers, this will be our solution. For number 2, we have 5 times 4, quantity cubed. So we have 5 and a 4, so we have two different bases. Again, we're going to take that exponent of 3 and distribute it to each of our bases, which is going to give us a 5 to the third power times 4 to the third power. And that will be our solution here. For number 3, we have 6a raised to the second power. So I'm going to have you try this one on your own. So go ahead and push pause. When you're done, push play, and let's see if you were right. So here we have a 6 and an a. We have two different bases. So our 2 will distribute to both, which will give us a 6 squared times an a squared. For our fourth example, we have 3x quantity squared. So I'm going to go ahead and have you do this one as well. Go ahead and push pause. When you're done, push play, and let's see if you're right. So here we have 3 and x, which are two different bases. We're going to take our square and distribute it to each of our bases. So we're going to have 3 squared times x squared. And here we've written the product of two powers. So here, a general rule might be that if we have a times b raised to the m power, that our solution would be a to the m times b to the m. Now let's talk about what happens when you find the power of a quotient. So we'll write the expression as the quotient of two powers. Then we'll write a general rule to find a power of a quotient. So here in our first example, we have 2/3 raised to the second power. We can have our 2 represent a base, and our 3 also represent a base. And we're going to take our exponent of 2 here and distribute to our numerator and to our denominator, which will give us a 2 squared divided by 3 squared. And this would be our solution. Now, if we wanted to continue this and simplify it farther, we would end up with 4/9 as a final answer if we were to continue simplifying or evaluating. Let's go ahead and do number 2. So here we have 4/3 raised to the third power. I'm going to have you do this one on your own. So go ahead and push pause, and then when you're done, push play, and let's see if you were right. So here we'll indicate the 4 as a base and the 3 as a base. We'll take our exponent of 3 and distribute it to our numerator and our denominator. So we'll have 4 to the third power divided by 3 to the third power. And here we have an expression of our quotient written as quotient of two powers, and we're done. If we take a look at our third example, here we have x over 2 raised to the third power, where our x is considered a base and our 2 is considered a base. So we'll take our exponent of 3 and distribute it to both the numerator and the denominator. which is going to give us an x to the third power divided by a 2 to the third power, and that would be our solution. I'm going to have you try number 4 on your own, which is a divided by b to the fourth power. So push pause, and then when you're done, push play, and let's see if you're right. So here, our a is considered a base, and our b is considered a base, and we'll take our exponent of 4 and distribute it to both our numerator and our denominator. So we'll have a to the fourth power divided by b to the fourth power, and that will be our final solution. Let's practice putting into place all of our properties of exponents, where we will simplify the expressions and write our answers using only positive exponents. So here for letter A, we have 2x squared, all raised to the third power. So the 2 represents a base, and the x represents a base. So we're going to take our 3 and distribute it, and that's going to give us a 2 to the third power times an x squared also to the third power. So here we know that when we have that 2 times 3, we get to multiply those. So we're going to get 2 to the third power times x to the sixth power. And because we're simplifying our expression, our final answer is going to be an 8x to the sixth, because 2 to the third is 8, and this will be our final answer. For letter B, we have 4 to the third, a to the seventh, all raised to the 0 power. Now we could distribute that 0 to each piece, however, since it's everything to the 0 power, and we know that anything to the 0 power is a 1, we're simply able to just write the number 1, because all of that was raised to the 0 power, and we're finished. For letter C, again we have 2 different bases, which was 4 and y, so we're going to distribute our fourth power, which is going to give us a 4 to the third raised to the fourth, and it's going to give us a y to the negative 2 raised to the fourth. From there, we'll have a 4 to the 12th times a y to the negative 8th, and because we want this written only in positive exponents, we know that our y to the negative 8 must move down to our denominator. So that's going to give us a 4 to the 12th over y to the 8th. Generally, when we have exponents as large as 12, we don't evaluate those, and so we would leave this as 4 to the 12th over y to the 8th. For letter D, we have x to the third divided by x squared, all raised to the negative 1 power. So because we have a negative 1 right here, we know that we're going to be able to simply take our denominator and move it up to the numerator, and our numerator down to the denominator. So we'll take each of these pieces and switch them. So we're going to have an x squared over x to the third raised now to the positive 1 power. But because we don't write things raised to the 1 power, that's going to leave us with an x squared over x to the third. And now notice here we have twin bases that are stacked. And we know that when they're stacked, we subtract. So 2 minus 3 is a negative 1. So that's going to leave us with an x to the negative 1 power. And we don't want to have a negative, we want all positives, so this will then become 1 over x. And this will be our final answer. We also could have done the subtraction prior to flipping. Let's take a look at letter E. Here we have 3x to the fifth divided by 3 to the third x, all raised to the negative 3 power. This one we're going to go ahead and do a little different so that you can kind of see what I meant on that last problem. So notice that here we have a 3 to the 1 power, then x to the fifth, and a 3 to the third, and an x to the 1. So if we notice here, we have same bases with our 3's, and so we're going to be able to subtract the 1 and the 3. So we're going to take 1 minus 3, which is negative 2. So that's going to give us a 3 to the negative 2 power. And here we have our x's, and we're going to be able to subtract the 5 and the 1. So 5 minus 1 is a 4, and so we're going to have x to the fourth power. So when we rewrite that, we have x to the fourth over 3 squared, because we want to have positive exponents. But remember that all of that was raised to the negative 3 power. So what we're going to do next is we're going to distribute that negative 3. We also could flip our 3 squared, or an x to the fourth, and multiply those by a 3 as well. Or we can do this. So like I said, we're going to do it this way so you can see that there's multiple ways to do it. So what this is going to give us is an x to the negative 12 over a 3 to the negative 6, because remember we get to multiply our 4 and negative 3 and our 2 and our negative 3. And then because we don't want any negatives, we will need to rewrite this as a 3 to the 6th power over an x to the 12th. Because our 3 to the 6th, our exponent here is bigger than a 5, we're going to go ahead and just leave it. And that's going to be our simplified expression. So for letter F, we have x to the 5th times y to the 3rd, all divided by x squared times y to the 3rd, all raised to the 7th power. I'm going to go ahead and let you try this one on your own. So go ahead and push pause, and then when you're done, push play, and let's see if you were right. So here we have x's that match, and we also have y's that match. So because they're stacked, we can subtract. So we're going to start off by subtracting our 5 and our 2. So 5 minus 2 is a 3. So that's going to give us an x to the 3rd power. And then we're going to be able to subtract our 3 and our 3, which is 0. So it's going to leave us with a y to the 0 power, which is really just a 1. So here we have x to the 3rd times 1. So we don't really need to write the times 1, so we'll leave that. And then all of that is raised to the 7th power. Because we have a 3 raised to the 7th power, we're able to multiply these right here. So that's going to leave with an x to the 21st. And that's going to be our simplified expression.